Hi everybody, my name is Sarah. I'm a graduate assistant here at the Math Zone, and today I'm going to be talking about quadratic functions and equations. For those of you in Math 1107 and 1108, this is going to align with Module 3, Sections 3.9 and 3.10. And our learning objectives today are to solve quadratic equations by the square root property, as well as the quadratic formula. Let's go over some definitions that will help you understand this content. First, what actually is a quadratic equation? A quadratic equation is a specific type of polynomial equation where the highest degree is 2. And we write this in the standard form ax squared plus bx plus c equals 0, where a, b, and c are all coefficients and a cannot equal 0 because it would cancel out your quadratic term. An example of a real equation written in this standard form is x squared plus 3x minus 4 equals 0, where a equals 1, b equals 3, and c equals negative 4. Next, we have the square root property. This states that if x squared equals k, then we know that x equals plus and minus the square root of k. And so an example of this with a real number would be that if x squared equals 9, then we know that x equals plus and minus the square root of 9, or since 9 is a perfect square, we can go one step further and say that x equals plus and minus 3. Finally, we have the quadratic formula. This formula states that negative b plus or minus the square root of b squared minus 4ac all over 2a. If we wanted to put an actual equation into this formula, we can go back to that equation that we looked at as an example of a quadratic equation in standard form, and we would plug in our numbers for a, b, and c, so we get negative 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 4, all over 2 times 1. Let's go over the steps on how to solve a quadratic equation using the square root property. First, you need to isolate your quadratic term and make its coefficient 1. What this means is that you need to take whatever term it is that's being squared and put it alone on one side of the equation. Once it's in that form, you can apply the square root property, and from there you can simplify your answer until you get your final solution. And you can always check your solutions by plugging them back into your original equation and making sure they get you the right answer. And my hint here is that you should always have two answers because you have a positive and a negative. Let's take a look at an example problem. So here we have 2c squared equals 128, and we want to solve using the square root property. So first we have to isolate our quadratic term. In this equation, our quadratic term is c squared. So first, we're going to divide both sides of the equation by 2 to eliminate the 2 that's attached to the c squared on the left side and get our quadratic term alone. This gets us c squared equals 128 over 2. And we can simplify this further to get c squared equals 64. Now that we've isolated our quadratic term, we can apply the square root property. The square root property states that if c squared equals 64, then c equals plus and minus the square root of 64. And because c is a perfect square, we can go one step further and say that c equals both positive and negative 8. Let's try a more challenging problem. So here we have 1 over 7 times 2a plus 5 squared equals 10. At first glance, this looks a lot more complicated than our last problem, but in reality, 2a plus 5 squared is your entire quadratic term. So all we have to do is get this term alone on one side of the equation. To do this, we're going to multiply both sides of the equation by 7 to eliminate the fraction on the left side. This is going to get us 2a plus 5 squared equals 70. Now we've isolated our quadratic term and we can apply our square root property. Remember, the square root property states that if 2a plus 5 squared equals 70, then 2a plus 5 equals plus and minus the square root of 70. Now we can solve for a. We're going to solve for the positive square root of 70 and the negative square root of 70 separately because we're going to get two different solutions here. So let's start with the positive. We have 2a plus 5 equals the square root of 70. We're going to subtract 5 from both sides of this equation. And then we're going to divide by 2 to get a alone. And this is going to get us a equals the square root of 70 minus 5 over 2. That is one solution to this equation. Next, we're going to do the negative. So we have 2a plus 5 equals negative square root of 70. Again, we're going to subtract 5 from both sides and then divide by 2 to get a alone. And this gets us a equals the negative square root of 70 minus 5 over 2 for our second answer to this equation. Next, let's go over how to solve a quadratic equation using the quadratic formula. Step 1 is to write the equation in standard form and identify the values of a, b, and c. Once you know your values for a, b, and c, you can substitute them into the quadratic formula and solve the equation from there. Again, you can always check your solutions by plugging them back into your original equation, and you should always have 2 solutions for a quadratic equation. Let's solve an equation using the quadratic formula. So here we have 3v squared minus 14v plus 5 equals 4v minus 5. The first thing that we need to do to solve for v is get one side of the equation equal to 0 so that it's in standard form. To do this, we are going to subtract 4v minus 5 from both sides of the equation. This gets us 4v squared minus 18v plus 10 equals 0. Now our equation is in standard form. In standard form, we can identify our a, b, and c values. And in this equation, a is equal to 3, b is equal to negative 18, and c is equal to 10. Remember that the quadratic equation is negative b plus or minus the square root of b squared minus 4ac over 2a. So we can go ahead and plug our a, b, and c into this equation. This will get us 18 plus or minus the square root of negative 18 squared minus 4 times 3 times 10, all over 2 times 3. Then we can simplify this by multiplying all of our values out. This gets us 18 plus or minus the square root of 324 minus 120 all over 6. And again, we can simplify further by subtracting those numbers, which gets us 18 plus or minus the square root of 204 over 6. And this is our answer to v in this equation. We have both a positive and a negative answer here. If you were ever asked to go further and find the square root of 204 with your calculator, and then do plus and minus to solve for 2 final numbers, you could do that, but most of the time, as long as you don't have a perfect square, leaving your answer in rational form like this is perfectly fine. Quadratic equations have many real-world applications, and I have some examples of those here. So for one, in physics, quadratics are used in both kinematics and optics, and here I have the example of somebody throwing a baseball. So a quadratic equation can be used to model the movement of any object that is thrown or dropped and has an arc-like shape to its movement. Quadratics are also used in engineering, specifically in structural engineering when trying to measure objects that are rounded, or in electrical engineering when making circuits. And finally, quadratics are used a lot in finance, specifically with interest and investments. And again, for those of you who are taking college math, you're going to revisit these concepts in Module 4. That concludes the presentation today. I want to thank everybody for watching, and I hope that you all learned something.